All right, the reason we use oblique rotation instead of orthogonal rotation is if we think that the new factors that are going to be created by factor analysis are correlated. Okay, so if they're correlated, you think they're going to be correlated. There's a way to check on that as well, but if you think they're going to be correlated, you should use the oblique rotation. What that means is it allows overlap between your new factors. Number two, which of the following should be removed that would bump up your reliability? Reliability is what we call Cronbach's alpha. So what you do is you go down here, you look at the largest Cronbach's alpha number, looking like that one. So if you got rid of this question, number 12, your Cronbach's alpha, or your reliability, would jump way up to 0.9156. Pretty easy. Moving on. Next question. So this question asks basically if the four new factors, 1, 2, 3, 4, are supporting Zuckerman's theory. So what you're looking at here is, so let's take this first one. This question, I drive too fast. What it's saying is it does load up under new factor number 2 a little bit, but under number 3 a lot. So the second one, Pink Floyd is the best band ever, which I agree with. Again, it loads up under number 2 the best, but also a little bit under number 1 and number 3, et cetera, et cetera. So when you got them loading up more than one place, that could be problematic. In other words, let's take this one. I hate the idea of bungee jumping. So it loads up under with number 1 a little bit, number 3 negatively, and number 4 a little bit. So these factors aren't exactly clear. Okay, they're not. The questions aren't loading up very well. So I'm going to say that no, these components do not support Zuckerman's theory very well. But what you're going to do, what you should do, is you should take those questions that are loading up under each of the components and run a separate factor analysis reliability on them and check that Cronbach's alpha. If it's greater than 0.7, you can leave them alone. Okay, but that's that one. All right, scrolling to the next one. So it wants to know out of which one of these three factors you should probably name preparation of fruits and vegetables. So find those questions or those abilities, skills that are dealing with preparations of fruits and vegetables, like chopping chili. Okay, that's a high number. It's highest under number 1. Slicing an onion, again, its highest factor is number 1. So I'm going to say number 1. Factor number 1 should be labeled preparation of fruits and vegetables. Next question. So it wants to know which factor should be labeled creativity. So again, pick those abilities that are creative, like cake decorating. So it's highest under number 8. Colors on a plate. Number 9 as under number 2, 0.9. So I'm going to say factor number 2 should be labeled creativity. Next question. Simple regression. All right, psychologist, blah, blah, blah. What does the standardized beta tell us? The betas always tell us the same thing. Look at the beta here. So it's negative 0.224. What that literally means is every time news goes up 1 unit, the DV, depression, goes down 0.224 units. I'll say it again. So what that beta weight means is for every 1 unit of increase on the news exposure, the DV, depression, goes down negative 2.24. So let's figure out which one that one is. So when news goes up by 1, depression decreases by 0.224. That's your right answer, number B. B is the right answer, okay? Next one. Okay, so they want to know what this number represents, 847.685. So in this ANOVA table, that's the sum of squares. This is 2 separate models, right? Regression 1, regression 2. You go down here to your C. This row 2 is the results of adding 2 predictors, gender and fantasy proneness. So what the correct answer would be is that this is the error term. Residual is error. So it's the total error in predicting fear scores when both gender and fantasy are included. That's that answer. Next. All right, next one. Psychologists interested in whether the amount of news people watch predicts how depressed they are in the table. So, what does this 3.03 mean? That is the mean square for the regression. So, the regression is the variance that you can't explain. So, that's the good number. Let's see which one's the ratio of how much prediction of prediction of depression has improved by fitting model compared to how much error still remains. No, 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 no. That's what the F is. The F is a ratio between good variance, which is the regression variance that you can explain, divided by bad variance, which is the residual that you can't explain. That's A, so that's not the answer. The ratio of how much error there is in the model, nope, that is not the error term. Again, regression is the good variance, stuff that you can explain, it's not error. So C is not clear. I'm not 100% sure what this one is saying, but I'm going to pick D. So that number 3.03, which is the mean squares of regression, is the proportion of variance that you can explain by news exposure. So I'm going to say this one's D. Next one. All right, same problem. What's the 4.404? What you have to know in an ANOVA, the F ratio is a ratio, okay? It is the amount of variance that you can explain divided by the amount of variance you cannot explain. So remember, the variance of the regression is explainable from the regression. The residual is your error term. So this F literally is 3.03 divided by 0.688. So in other words, you have 4.4 times as much variance that you can explain than what you can explain. So let's go over the answers and see which one best fits. So the ratio of how much prediction of depression has improved by fitting the model compared to how much variability there is in the depression scores? Nope. The ratio of how much prediction depression has improved the fitting model compared to how much error still remains. That's probably the answer. Okay, I think B is the answer. So number C, the ratio of how much error there is in the model compared to how much variability. The variability is too generalized. That's not the right answer. Proportion, number D. Proportion of variance in depression explained. Nope. I'm going to stick with B. Okay. So B, it looks like the right answer. It's the ratio. An F score is a ratio of explainable variance divided by unexplainable variance. In other words, the regression variance divided by the residual variance. That's what the F score is. Okay, so number 10, R squared is basically it's the percent of the variance that you can explain, right? I'll say that again. R squared is the percent of the variance in the DV, or the outcome variable, that you can explain by whatever your model is. So let's look at your options here. Percentage of variance in the outcome of the DV accounted for by the predictor variables of variables. Boom, that's it right off the bat. A. Okay. B is not right. C is not right. Let's see D. The proportion of variance in the outcome accounted for the predictor variables, or proportion or percentage. See, these questions, they all basically mean the same thing. The proportion of variance or the percentage of variance. They look like the same answer to me, so it's either A or D. I'm going to pick A. Next one, number 11. Recent research has shown that blah, 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 blah. Let me read this. Okay, so it looks like they ran a regression. It looks like she's asking you, or the teacher's asking you, what type of regression has been carried out. And the good news is, it's right there, stepwise. Stepwise means it puts in one predictor at a time, and the computer does the software, or the software does the heavy lifting for you. It will decide which of the predictors are strongest and significant, and only use those significant predictors in the model for you. So the researcher doesn't have to do much of anything. So that's my final answer, a stepwise regression. It'll say right there, stepwise regression or hierarchical. So that was easy. Let's do number 12. Okay, so what's this question? Which of the predictors variables does not predict burnout? So you simply go to your predicting model. I always go to the last one because that has all of your variables: perceived control, coping ability, stress from teaching, stress from providing pastoral care. You go to your significance box, bam, 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 And so these were all significant variables, right? Because they're all significant. Down here, because you use this stepwise, the software excluded these variables because they were not significant. So in other words, these predictor variables were not very good at predicting, right? You just look at the significance. Actually, significance of teaching was significant. I don't know why it was excluded, but stress from research was not. Stress from providing pastoral care was not. Stress from research was not. Stress from providing pastoral care was when you put them in that model, right? So you got some kind of weird interaction going on this one, and then stress from research. Okay, so, but again, these were the variables that were excluded, except for stress from teaching in this model is considered significant. The other two were not. Hope that helps. Let's do the next one. Looks like you get another regression model, and she wants to know how much variance in burnout does the final model explain. So final model is the last one, 3, and you go to your R squared, so 0.803. So about 80.3% of the variance in the DV, burnout, can be explained by whatever model you're using there. So that's actually pretty damn good. And let's go to the next one. So they're asking about the beta value, B weight. So be careful, there's 2 B weights. One's the unstandardized B weight here, and one's the beta weight. So they are different, right? The main difference is the unstandardized coefficient B weight, it uses the same units as whatever you're measuring in, and the standardized B weights, it switches over to Z-scores. So they're standardized. That's why we call them beta weights. But let's see what her options are. And what's the question? How would you interpret a B weight for stress from teaching? Stress from teaching, stress from teaching, stress from teaching. Let's go to the last model, and its beta weight is negative 0.387. So what that means is when stress from teaching goes up 1 point, burnout goes down by 0.387. So these beta weights are the change in the DV. When these predictor variables increase by 1 unit, the burnout, the DV goes down by that many units. Okay, so let's see which one of these is which. As stress from teaching increases by that, what the hell? That ain't it. As stress from teaching increases by a unit, burnout increases by, that's almost right. If that was decreases, that would be right. So it looks like number C, as stress from teaching increases by a unit, burnout decreases. This is your number. Right there, C. Got it? Good. Next. Oh, that was the last one. Okay, so I'm going to go ahead and send you a list of videos to watch that would explain all of this. These are all in HOG 3, and that's it. MGZ out.